Vector OA and OB are position vectors relative to the origin O. Given the points A is 7, -15, and B is -2, 3, write down the column vectors OA and OB. So if we want to know what OA is, we're just going to take A, and instead of writing it horizontally, we're going to write it vertically. So we put 7 on top and we put -15 at the bottom. And so that is what OA is. As written as a column vector, it's going to be 7 and -15. And then we have OB. We're going to do the same thing. We're going to write B. Here it's written horizontally, but we're going to write it vertically. So OB is actually equal to -2 on top and 3 at the bottom. And so that's how we can write OA and OB as column vectors. Next, we have to express AB as a column vector. Now, AB is going to be equal to AO plus OB, all right? So AB is equal to AO plus OB. And it makes sense because when you think about it, imagine that you have, let me use a different color. Imagine if you have, say you have the point A, all right? So imagine that you have the point A, right? And O is the origin, and imagine that you have the point B, right? So if you're trying to get from A to B, well, you go from A, so this is O, right? So you go from A to O, and you go from O to B, all right? And so that's why we have AO, so A to O, and then we have O to B, so O to B. So that's the way that you could think about what's happening here. So let me erase our link. So let's erase our link. So we have AB, the vector AB is equal to AO plus OB. Now, we do know based on our previous question, we do know what, well, that's the thing. We do know what OB is, right? We know what OB is. OB is -2, 3, right? So we know what OB is. The only thing is we do not know what AO is. We don't know what AO is. But the good thing is we have OA. And so all we have to do is switch the letters. And so we have that AB is equal to AO plus OB. We know what OB is, but we don't have AO, but we have OA. So we're gonna switch the letters. So we switch it from AO to OA because we have what OA is. But the problem is that every time, or I should say the penalty is that anytime you switch the letters, you have to put a negative sign out front. So you can switch the letters, that's fine, it's no problem. But the penalty for switching the letters is you have to attach a negative sign here. Otherwise, these two will not be equal. So you have to attach this negative sign. Okay, so what do we have now? We have OA, we have OB, that's fine. We know what OA is. OA is 7 and -15. Don't forget to put the negative sign because we put the negative sign here, and we did it because we switched the letters, and the penalty for switching the letters is putting the negative sign. So keep your negative sign. So, and then we have 7, -15 because that's what OA is. We figured that out in the previous question. And then we have OB. OB is -2, 3. And so we have to simplify these two. So we have to say, okay, negative times 7, -1 times 7 is a -7. And negative times a negative is positive. So -1 times -15 is +15. Just bring down the -2 and 3. Next, we say -7 plus -2 is equal to -9. And then we say 15 plus 3. Well, 15 plus 3 is 18. So AB is equal to -9, 18. That's what the vector AB is, -9 and 18. Okay, so next we need to calculate the magnitude of vector AB. Now, in general, if AB is equal to Mn, then the magnitude of AB denoted as follows is the following. So here's the formula in general for the magnitude of a vector. And so the magnitude of a vector is going to be equal to, we take the square root of the coordinate that's on top, or the component that's on top, so it's going to be m squared. So we take the square root of m squared plus n squared. What does that mean? Well, m squared, m is the coordinate or the component that's on top, so we square that, and we take the component that's at the bottom, and we also square it. So we square both components, we add them, then we take the square root of that sum. So again, so in general, how do we find the magnitude of a vector that is a column vector that only has two components? Well, we square the first component, we square the second component. So we square the first component, we square the second component, we add them, and we take that sum, and then we take the square root of that sum. Okay, so that's basically how we find the magnitude of a vector, of a column vector with two components in general. Okay, so that means that we can do that. So AB is equal to -9 and 18, and we evaluate the magnitude in the following manner. We have that the magnitude of AB is going to be equal to, so we have -9 squared plus 18 squared. So we square the first component, we square the second component. And so -9 squared is 81, 18 squared is 324. We have to add these two results, and we get 405. And so the magnitude of AB is the square root of 405. And the square root of 405 is 20.1246118. Next, we write this correct to 2 decimal places. And we pay close attention to this number. This number is less than 5, so we cannot round up. And so that means that AB is simply going to be 20.12, correct to 2 decimal places. And that's our answer to this question.